Yeah, good evening all. Now I am going to explain about state space analysis. This is very important topic. From this topic at least you will get 2 questions. Okay, now see here in this state space analysis, okay, here number of state variables is equals to number of energy storage elements, right? Number of energy storage elements is nothing but inductor and capacitor are the energy storage element. If the circuit is having only one inductor and one capacitor, then the number of state variables is equals to 2. Okay, in this way we can find out state variables. Number of state variables is equals to number of energy storage elements. Okay, next see here in state space analysis the representation will be x dot is equals to a into x plus b into u. Okay, y is equals to c into x plus d into u. Okay, where a is state matrix, where b is input matrix, c is output matrix, d is disturbance matrix. Okay, now see here, let us consider a differential equation d cube y by dt cube plus 3 into d square y by dt square plus 6 into dy by dx plus 10 into y is equals to 2 into u. Okay, for this given differential equation, from this given differential equation we need to find out the state transition matrix, or we can represent this given system into this form, that is x dot is equals to ax plus bu, y is equals to cx plus du. Okay, let us assume y is equals to initially x1. Okay, after that y dot is nothing but first derivative, y dot is equals to, can apply differentiation on both sides, y dot is equals to x1 dot, that x1 dot is equals to x2. Okay, similarly next again differentiate this y dot, you will get y double dot, x1 differentiate again, then x1 double dot, that x1 double dot is equals to x2 dot, that is equals to x3. Next again differentiate this y double dot, you will get y triple dot, that means differentiate 3 times, that is equals to x1 triple dots is equals to x1 triple dot is equals to x2 double dot, that is equals to x3 dot. Okay, now see here, this is third differential equation, right? That means y triple dot plus 3 into second order differential equation, that is y double dot plus dy by dx will be 6 to y dot plus 10 into y is equals to 2 into u. Okay, now see here y triple dot is equals to x3 dot. Next 3 into y double dot is equals to, I can replace with x3, that is 3 into x3. Similarly y dot is equals to x1 dot, that is equals to x2 plus 6 into x2. Next y dot is equals to x1 dot, that is equals to x2, right? Then see here total equation will be y triple dot is equals to x3 dot, y double dot is nothing but y double dot is equals to x3, right? That is 3 into x3 plus y dot is equals to x2, this 6 into x2 plus 10y is equals to 2u. Okay, now from this equation x3 dot is equals to, I can take this term on RHS side, right? That is minus 10x1 minus 6x2 minus 3x3 plus 2u is the equation, right? That is x3 dot. Now if I represent in matrix form, already we calculated, remember this point, this is common for all differentiation, x1 dot is equals to always x2, x2 dot is equals to x3. Okay, now see here, what is the x1 dot equation? Only x2, right? That means first term will be 0, second term is 1, third term is 0, that is x1 dot is equals to 0 into x1, you will get 0. Next 1 into x2, x2, 0 into x3, x3, sorry 0 into x3, x0, right? Then x1 dot is equals to only x2, satisfied. Similarly x2 dot is equals to x3, right? 0 0 x3 only, right? Next x3 dot is equals to minus 10x, that is minus 10x minus 6 x2 minus 3 x3, right? Next plus 2 into u, right? That is, this is input matrix, right? This is u of t is nothing but input. Okay, this input is having x3 dot term, right? that means ax plus b, right? 0 into u, first x1 dot doesn't have u term, 0 into u, x2 dot also doesn't have any u input term, right? That is 0 into u. Only x3 dot is having input term, that is 2 into u. In this way we can represent. Okay, next output y is equals to, see here, output y is equals to only x1, right? Based upon first assumption, that is y is equals to 1 into x1, only x1. Next remaining term 0 into x2 0, 0 into x3 0. Okay, in this way we can form a matrix. Now see here, to remember this formula, just follow simple step. First x1 dot is equals to x2 means only one term is present at first row second column, right? Next similarly x2 dot is equals to x3, right? That means second row third element is only 1. Next see here, third element x3 dot is equals to, you can write the terms from left, my right hand side, right? First starts from 10y, right? After that 6, after that 3, right? This is a 3 by 3 matrix, right? You can change the sign here, plus 10y is right, plus 10y is there, right? This plus 10 is represented by minus 10 here. Okay, next 6 into dy by dx, that means 6, right? This 6 will be represented by minus 6 here. Next plus 3 is represented here, minus 3. Okay, reverse order, minus 10, minus 6, minus 3. Okay, if you see, like if you draw like this, then the problem is very simple. By seeing the option only you can choose the answer. Okay, in this way we can solve problem. When differential equation is given, we can find out the transfer function. Okay, next, if transfer function is given, then how to find out the state space analysis? That means we need to represent the given transfer function into state space analysis. That means x dot is equals to ax plus bu form, and output y is equals to cx plus du form. Okay, now see here c of s by r of s, what is given? 3s square plus 6 divided by s square plus 9s plus 4. Okay, based upon s power n term, okay, we can say that the order of matrix s power 2, right? That means the given matrix is 2 by 2 matrix. Okay, now see here, to solve this problem, just remember these two formulas. S power n is represented by x suffix n dot. X suffix n dot is equals to x suffix n plus 1. Okay, now see here, what is given? C of s by r of s is equals to 3s square plus 6 by s square plus 9s plus 6. Okay, here s power 2 is there, right? That means 3 into, based upon this formula, s in place of n is equals to 2, right? S square is equals to x2 dot, right? That means 3 into x2 dot plus 6 into this value can be written as 6 into s power 0. That means x naught dot, okay, based upon this formula, divided by next x2 dot plus 9x1 dot plus 6x naught dot. Okay, this is the representation. After that, x2 dot is the highest term, right? That means you cannot change this x2 dot. Okay, you cannot write x2 dot is equals to x3. Why? Because we need the equation in terms of x2 dot. Then after that, x naught dot is equals to x of n plus 1, right? That is x0 dot is equals to 0 plus 1 x1, right? That is 3x2 dot plus 6x naught dash x naught dot divided by x2 dot plus 9x1 dot plus 6x naught dot, right? Here 3x2 dot y is equal, this y value is 3x2 dot, x naught dot is equals to, based upon this formula, x1. Similarly, u is equals to x2 dot plus 9x1 dot can be written as 9x2 plus 6x naught dot can be written as 6 into x1, right? From this equation, x2 dot is equals to, I can take this term to LHS side, right? That is minus 6x1 minus 9x2 plus u, that is equation 1. Okay, next, output y is equals to, see here, output y is equals to 3 into x2 dot, right? Already we know x2 dot value, that is substitute here, minus 6x1 minus 9x2 plus u. Then output y is equals to minus 18x1 minus 27x2 plus 3 into u, right? Next, already we know that from this formula, x1 dot is equals to x2, right? then the equation will be x1 dot is equals to x2, right? That is 0 into x1, this value is 0. Next 1 into x2. Okay, that means x1 matrix is over. Next similarly for this x2 dot is equals to minus 6x1 minus 9x2, right? Minus 6x1 minus 9x2. Next plus u, right? Whereas x1 dot doesn't having any input term, right? That means x1 value here it is 0, right? x2 term will be only 1. Next output y is equals to minus 18x1 minus 27x2 plus 3 into u, right? See here output y is equals to minus 18x1 minus 27x2, right, plus 3 into u. Okay, in this way we can represent input matrix, the given transfer function into state space analysis. Okay, next solution from the state space analysis. Okay, for example, suppose if a matrix is given, right, if a matrix is given like this, x1 dot, x2 dot, x3 dot is equals to ax plus b into u, right? Next output y is equals to c into cx plus here d value will be 0, right? If the matrix is given in this form, then how to find out the transfer function means, already we know a matrix, b matrix, c matrix, right? First we need to find out si minus a. Okay, I is nothing but identity matrix. Okay, si minus a whole inverse. Okay, starting c into si minus a whole inverse into b plus d. Okay, generally this disturbance value will be 0. Then transfer function value is c into si minus a whole inverse into b. Okay, for this equation, if we want to find out a complete solution of a state space equation, okay, if we want to find out the transfer function, we need to use this formula. If we want to find out the complete solution of state space equation, is formula will be Laplace inverse of si minus a whole inverse into x of 0. This value will be mentioned in the problem. Next, plus Laplace inverse of si minus a whole inverse into b into, in here we need to consider u of s matrix. Okay, that means total complete solution is having natural response plus forced response. Okay, this Laplace inverse of si minus a whole inverse is represented by phi of t. In some textbooks it will be represented by e power at. Okay, that is x of t is equals to phi of t into x of 0 plus phi of t into b into u of s. Okay, where phi of t is equals to Laplace inverse of si minus a whole inverse. Now these are the some properties of phi of t. Okay, here phi of 0 is identity matrix. That means if we substitute in place of t is equals to 0, then the resultant matrix is identity matrix. Okay, here phi inverse of t is equals to phi of minus t is the another property of this function phi of t. Next, phi of t2 minus t1 into phi of t1 minus t2 is equals to, we can written as phi of t2 minus t0. This is the another property. Okay, next, phi of t whole power k is equals to phi of kt. Okay, now we will solve one problem on when a state transition matrix is given, how to find out this transfer function. Now see here, x1 dot, x2 dot matrix is, a matrix will be minus 4, minus 1, minus 3, minus 1. B matrix will be 1, 1. C matrix will be 1, 0, right? A, B, C is given, right? First we need to find out Si minus A, right? Okay, that means this is 2 by 2 matrix. Identity matrix will be 1, 0, 0, 1, right? Multiply with S, right? Then you will get S, 0, 0, S, Si minus A. This is A matrix. Okay, if I simplify this equation, I will get S plus 4, 1, 3, S plus 1. Okay, this is 2 by 2 matrix, right? Next, I need to calculate Si minus A whole inverse. Okay, A inverse is nothing but adjacent A by det A, right? That formula will be Si minus A whole inverse. This is det A, that is 1 by AD minus BC, right? For example, S plus 4 is A, 1 is B, 3 is C, S plus 1 is D, right? Then determinant will be 1 by AD minus BC, that is 1 by S plus 4 into S plus 1 minus of minus you will get plus, right? Plus 3. Then if I simplify this equation, this is determinant. Okay, Now see here it is A, B, C, D, right? For determinant 1 by AD minus BC into, here you will get D, here you will get A, here you will get minus B minus C, right? That values will be S plus 1, minus 1, minus 3, S plus 4. Okay. Then Si minus A whole inverse is equals to, this is determinant value. If I simplify determinant, I will get this value S plus 1, minus 1, minus 3, S plus 4, right? Okay. After that, I need to multiply this Si minus A whole inverse with B. B matrix will be like 1 and 1. Okay, that is S plus 1 into 1, S plus 1, minus plus into minus again, minus 1 into 1, 1, right? S plus 1 minus 1, you will get here S. Next minus 3 into 1, minus 3, plus S plus 4 into 1, S plus 4, minus 3, that value will be S plus 1, right? Then after that I need to multiply with 1 into 0. If I simplify this equation, I will get S by S square plus 5S plus 1 is the transfer function. Okay, in this way we can find out the transfer function. Okay, next, controllability and observability, very important, right? See here, already we know that x dot is equals to ax plus b bu, y dot y is equal, output y is equals to cx plus du, right? Now see here, if the given system is a controllable, that determinant m value should not be equals to 0. Okay, where m is equals to b into ab into a square b, so on, a power n into b. Okay, similarly for observable, m is equals to, it is a, for controllability it is a row matrix, for observability it is a columnar matrix. Okay, for controllability also this determinant value should not be equals to 0, then only it is observable. Otherwise when m is equals to 0, it is not observable. Okay, now if we solve one problem, x1 dot is equals to x2 dot is equals to 1, 1, minus 2, minus 1. Okay, that means A matrix is what is given, 1, 1, minus 2, minus 1. B matrix is 0, 1. C matrix is 1, 0, right? From this given question, first option is controllable and observable. Second option is controllable but uncontrollable but unobservable. So third option is observable and uncontrollable. Fourth option is uncontrollable and unobservable. Okay, for controllability, what is the test? B into AB. First consider only first two elements, B into AB. What is the B value? 0, 1. Next AB. What is the A matrix? 1, 1, minus 2, minus 1 into B value is 0 into 1, right? 1 into 0, 0, plus 1 into 1, 1. You will get 1, right? Next minus 2 into 0, 0, plus minus 1 into 1, you will get minus 1. AB value is minus 1, B value is 0, 1, right? B, AB. First, in first column you are having 0, 1, next 1, minus 1. See here, AB value is 1 minus 1, B value is 0, 1. First column is B, second column is 1 minus 1, right? That is 0, 1, 1 minus 1. Now the determinant 0 into minus 1, 0, minus 1 into 1, minus 1. Minus 1 is not equals to 0, right? Hence it is controllable. Similarly, for observability, okay, here I am representing with n, right? First C and CA. Already C value is known, right? What is the C matrix here? 1, 0, right? C matrix is 1, 0. Next, I need to calculate C into A. C is 1, 0. A is 1, 1, minus 2, minus 1, right? Next, multiply these two matrices. 1 into 1, 1, plus 0 into minus 2, 0. That value is 1. Next, 1 into 1, 1, plus 0 into minus 1, 0. That means 1, right? You will get 1, 1. First row matrix is 1, 0, C. Next, second row is 1, 1. 1 into 1 minus 0. 1 not equals to 0, hence observable. That means from the given options, it is controllable as well as observable. First option is correct. Next, see some standard formulas. If your transfer function is given as b into c3 into s cube plus C2 into S square plus C1 into S plus C naught divided by S power 4 plus A3 into S cube plus A2 into S square plus A1 into S plus A naught. Okay, from this given transfer function in controllable canonical form representation. Okay, this is in controllable canonical form representation form. State space analysis is in controllable canonical form representation. See here S power 4 term means 4 variables, 4 state variables are present. Okay, next, already we know that x1 dot is equals to x2 when 4 variables are present, x2 dot is equals to x3, x3 dot is equals to x4, right, based upon the previous formula. X power n dot is equals to x power n x of n plus 1, right? Okay, from those equations, these 3 equations you will get, right? Next, to calculate this x4 value, you can write these parameters, okay, from my right hand to left hand side by giving negative sign. See here, minus a naught, minus a1, minus a2, minus a3. Next, this x4 dot only is having input u of t, right? After that, y of t is equals to c0, c1, c2, c3. Okay, in this way we can represent the canonical, that means controllable canonical form. Suppose same transfer function should be represented in observable canonical form. That means first you need to represent in controllable canonical form. Okay, after that we can, okay, just we can transport the given matrices. That means A transports, B transports and C transports, then you will get observable canonical form. That means rows is replaced by columns, columns are replaced by rows. Now see here, what is the first row? 0 1 0 0, right? This is replaced with first column, that is 0 1 0 0. Next, second row 0 0 1 0, right? 0 0 1 0 is replaced with second column 0 0 1 0. Next, third row 0 0 0 1 is replaced with third column 0 0 0 1. Next, minus a naught, minus a1, minus a2, minus a3, right? Fourth row is replaced with here fourth column minus a naught, minus a1, minus a2, minus a3. Similarly, here input matrices. Now see here 0 0 0 b, right? B into u casta here c0, c1, c2, c3, right? That means C term is replaced with here B term. C0, C1, C2, C3. Row and columns are interchanged. Similarly here, C term is replaced with here B term. 0, 0, 0, B, right? But here it is in row, here it is in column. In this way we can represent in observable canonical form. Okay. Suppose if the given transfer function in B into C2 into S square plus C1s plus C0 divided by S plus P1 into S plus P2 into S plus P3. Okay, then that transition matrix will be direct here minus P1, minus P2, minus P3. In this way you will get the matrix. Okay, in this way we can represent this given equation L1, M1, N1, L2, M2, N2, right? That is, here B1 is equals to L1, L2, M1, M2 is equals to B2, B3 is equals to N1, N2. Okay. From these equations we can calculate all those values. Okay. Next, for repeated poles, same, you can represent poles here only. First repeated poles, after that non-repeated poles. Okay. Then y of t is equals to B1, B2, B3 into x of t. Here B1, B2, B3 values, right? Next 0 1 1 into u of t. For repeated poles, that is Jacobian canonical form. Okay, this is diagonal canonical form. In case of diagonal canonical form, poles will be represented only in diagonal elements. Remaining values will be 0. Okay, in this way we can solve the problems in state space analysis. In state space analysis, only one topic is pending, that is from signal flow graph to how to determine state transition matrix. Okay. Thank you all.